All right, so you've all measured yours. Mine's going to be a little bit different. I got 120 for mine. Okay, whatever you get. Okay, now, what I want you to do the same thing, but I want you to find the measure of angle POL.
Oh,
I wonder what it's going to be. Get to work. Do that, please.
same thing.
All right, so I measured mine, and you should get that this is 120 degrees. Huh. Or whatever you get. Okay, doesn't have to, yours is going to be different than mine because you guys drew different lines. But notice that these two angles are the, if they have the same measure, then those angles are congruent. Okay, that's the definition of congruent angles. So what I want you to do is let's mark on your paper that these are congruent. Let's write that that this angle is congruent to this angle with a single arc mark. Okay? And somewhere on your paper, I want you to write, okay, that angle JOE, somewhere on your paper, is congruent to angle POL.
You're so hilarious.
It's good stuff, isn't it? Isn't it funny? Isn't this cool? All right, now the next thing I want you guys to do is take your protractor and I want you to measure angle JOP. So over here, I'm going to write angle JOP. Okay, go ahead and measure that and see what you get. All right, show me what you got. Okay, so I've measured mine. Mine is 60 degrees. Okay, so it's going to be a little bit different than yours. Okay, now I want you to find the measure of angle EOL. Y'all. All right, so as I measured this, I found out that angle EOL was also 60 degrees. Okay? So what we know, all right, is, well, they're congruent. Angle JOP is, well, okay, saying that their measures are the same, which is what you're saying, okay, is the same thing as saying congruent. Congruent means they have the same measure. So you can say that their measures are equal, or you could say that they are congruent, that the angles are congruent. I like the word congruent. This is fun. I just like the little tilde that's above the equal sign. I like writing that. Okay, so angle JOP is equal to angle EOL. Hello. All right, so because these two angles are congruent here, okay, JOP is 60, so is EOL is 60. Let's mark off with two arc marks that these are congruent. Okay? Now, do you guys know what we call these angles that are across from each other? Hold on, I'll wait. So, because these angles that are across from each other are congruent, okay, does anybody have an idea what we call these kinds of angles? Well, they are congruent, but they have a specific name. They're not reflective.
Are they reflective though, technically? Because they're reflected.
Kind of, yeah. Okay, we call these vertical angles, so I want you to write that, okay, next to these. Okay, so vertical angles. Vertical angles, okay? So, and that's when, if two lines intersect, like these two lines intersect, angles that are across from each other are vertical angles, and vertical angles are always congruent. Okay? Now, we've measured these out, these angles, somewhere in your paper. Okay, I want you to write, let's do this. Let's take angle JOP, so write this down, angle JOP plus angle JOE, okay, and that's going to equal angle POE. Now, before I do anything, what do you guys notice about the angle POE? What kind of angle is that? It's a straight angle. This angle right here, it's a straight line. How many degrees do you get when you have a straight line? You get 180. Now here's what I want you to do. I want you to take whatever you got for JOP. In my case, I got 60 degrees. Okay? Plus angle JOE. In my case, I have 120. Yours is going to be unique. And let's see if you measured these correctly. So 120. Yeah, if that's what you got, that's good. And if you add those up, you should get a total length of 180 degrees. Okay, so check to see, take the number that you got for JOP, add it to the angle measure you got for JOE, and you should get 180, or at least very close to that. Okay, give that a shot. Show me that. Okay, the next thing I want you to do is, let's think about if I take angle JOE, so watch what I do here. I'm going to do another one, so write this down. Angle JOE plus angle EOL, okay? If I add those together, those two angles, okay, this angle and this angle, then I get JOL, okay? Now, what do we know about angle JOL? That's a straight angle. That's 180 degrees, okay? So, we know angle JOL is 180 degrees, okay? Now, for angle JOE, I got 120, okay? So write this down, whatever you got for your angle, plus angle EOL, which I got was 60 degrees, okay? And if I add those two numbers together, I get 180, all right? So now let's think about this, okay? We could do this for all the other angles. What do we call two angles that add up to 180?
Straight line. No, they're linear. They're okay. What does it start with? It starts with a P or something. They're linear pairs. No.
That they are linear pairs, but if you have two angles that add up to 180, do we know what that's called? Have we talked about that yet?
Oh my gosh. No, don't say it. What does it start with?
An S.
Oh my god, I know it.
Okay, so write this down. Two angles on your paper, two angles that add to 180 degrees are supplementary.
Yes, and complementary. Yes.
Supplementary. All right, we'll talk about that later, here in a minute. Okay? But these lines here, okay, form a linear pair. These angles here form a linear pair. So I'm going to write that down too, a linear pair. Okay? And a linear pair means you have two adjacent angles that, or I'm sorry, whose non-common side, whose non-common rays form a straight line. Okay, hence the name linear pair. So linear pair, the root word is line. Okay, and those are two adjacent angles whose non-common rays form a straight line. So here's the deal. All right, you can have adjacent angles. Adjacent angles means angles that are next to each other. So you have this angle here, all right, and you've got this angle here. What I know about those is that they are next to each other, all right? But what the other thing that I know is that they're non-common sides. This is the common side. This forms a straight line, okay? Because that forms a straight line, I know that these two form what's called a linear pair, which means they are supplementary, which means that their angles add up to 180 degrees.
You need to write what's on the side.
Yeah. You should be writing everything I'm writing down.
It's just harder to read.
No. All right, so we went through that activity. I'm going to start the notes right now, and this is Unit 1, Section 5. This is linear pairs and vertical angles, two things that we talked about and discovered. Okay, and these lesson objectives we want to calculate angle measures by using the definitions and theorems about linear pairs and vertical angles. Okay, we want to be able to identify linear pairs and vertical angles from given diagrams, and we want to use them to prove statements about linear pairs and vertical angles. Okay. So what we have is we have two intersecting lines, okay? And we can tell a lot of, if you have two intersecting lines, you can tell a lot about the angles associated with those, okay? So if you have two intersecting lines, you either get a linear pair, which means that you have angle measures summed to 180, and you have vertical angles which are congruent, okay? This is in your notes. I would have your notes out and be going over this if I were you, all right? All right, so what we have is we have linear pairs can be formed by intersecting lines. So linear pairs, okay, we've already kind of talked about this. These are adjacent angles that create a line. Okay? So for example, okay, if I have angle ABD, okay, and angle DBC, okay, those are adjacent angles, and then what they do is when you put them together, you create a line here, okay? So that's what we have, adjacent angles that create a line. So one pair of a linear pair would be angle ABD, and angle DBC, okay? All right? And the idea, guys, is that they form, big thing is that they form this line like that. Okay, we have a number of them in here. We actually have 4 linear pairs. Okay, you've got these two angles that you can use. Okay, you have these two angles whose opposite sides create a straight line, and you have these two angles create the same line here, and these two angles that create a line. Okay, so you've actually got 4 of them. All right?
What do you want us to do with this?
Okay, let's take a look at this next question. And so what you have here is you have this figure here. You have two intersecting lines. You've got line BD intersecting line CE at point A. Okay, and it says, which are linear pairs? Check all that applies. So linear pair means that two adjacent angles whose opposite sides or non-touching sides make a straight line. So here's what I've got. Let's take a look at DAE. So DAE and EAD. Now those are the same. It's the same angle, so that's no. Okay, that's not one that we want to put in. Okay. The next one is angle BAC, so BAC, this angle right here, and CAD, okay? And this is a linear pair, so BAC and CAD, because it forms this straight line going all the way across, then that is a linear pair. So I'm going to circle that one, yes. Okay, the next one, angle BAE and EAD, okay, and that is one. So here's what I've got. I've got BAE and EAD. That forms a straight line, okay, like that. And so that is also is a linear pair, okay. The next one, EAD, so EAD and DAC, okay, and that is one. So if I do EAD and DAC, then this also forms a straight line, okay. Therefore, this one is also a linear pair, okay. And then we've got CAE. CAE is a straight line, and BAD. No, those are not. They do not touch. They are not adjacent angles. They simply just intersect, and that's it. Okay. So now, Okay, so we have this thing called the vertical angles theorem. Okay, so if two angles are vertical angles, then they are congruent angles. So vertical angles are opposite non-adjacent angles formed by two intersecting lines. So here's what I've got, and we kind of discovered this, but I know that so angle BAC, okay, this angle here is across from angle DAE. So angle DAE, and both of those are congruent, and they are vertical angles. So they are across from each other. That's what vertical angles mean. Okay, then the other one is angle BAE. Okay, this angle here is then congruent to angle CAD. Okay, both of those. Okay, so they're across from each other. All right, so anytime you have two intersecting lines, you have two pairs of congruent angles that are across from each other. Okay, here it says identify any vertical angles in this diagram. So what I have is what I notice is I have these two intersecting lines here. So as a result, I'm going to draw congruent symbols here and here. All right, but then when I have those two intersecting lines, I have these two angles that are congruent. Then I also have this entire angle is congruent to this entire angle. And I'm going to write that down. I'm going to say that CAE is congruent to BAF. All right, so I'm going to write the pairs out. I'm going to say that angle CAB is congruent to angle EAF. Okay, and then I'm also going to say that angle CAE is congruent to angle BAF. Okay, and so they're just angles that are across from each other. Now notice that this line doesn't go all the way through. Okay, it stops at point A, so there's nothing on this other side, therefore we can't make any conclusions about these two angles here, okay? Okay, on this next page, it says, which are vertical angles? So check all that apply. And so let's take a look here. I'm just going to take a look at this picture here real quick and kind of do the same thing that I've been doing. Call these two angles here congruent because they're across from each other. So I have these two intersecting lines. This line doesn't go all the way through. Okay, and then I've got these two pairs of vertical angles. Okay, because they're across from each other. So let's take a look. I've got EAB and BAC. Okay, those are not vertical. Those are actually form a linear pair, but they're not vertical. So that one doesn't work. EAB and CAD. Yes, those are vertical angles. They are across from each other, so I'm going to go ahead and call that true. Okay, the next one, CAD and FAE. No, those are not across from each other, so that one doesn't work. And then CAB and DAE, that's the other one. Okay. And then DAC and DAE, that one doesn't work either. Okay, so you only had two pairs there, those two. Okay, the next one we have is a proof. Okay, and the proof is that we have this given statement. Okay, that angles 1 and 3 are vertical angles. We want to prove that angle 1 is congruent to angle 3. Okay, so this one's kind of an interesting proof. You have two intersecting lines here. So therefore, if your angles are across from each other, they are vertical angles, okay? And if they are vertical angles, then they are congruent. So it's kind of an interesting proof. It's pretty easy, actually. But what we know is that angle 1 and angle 3 are vertical angles, okay? And that's statement 1, and that's given to you. Okay, Merry Christmas, Happy New Year. Okay, or Happy Kwanzaa, Happy Hanukkah, whatever you celebrate. Okay, so here's what we know. Okay, if angles 1 and 3 are vertical angles, then we know that they're congruent, which is coincidentally the statement that we're trying to prove. So it's really not too bad Angle 1 is congruent to angle 3, and that's the definition of vertical angles, okay? So the reason, that's the definition of vertical angles, okay? Pretty easy, not too bad, all right? Okay, the next one, okay, same thing, okay? We know that, that angles 2 and 4, you have two intersecting lines here, line M and line N, and they intersect at point P, okay? So we know that 2 and 4 are vertical angles. If they are vertical angles, then we know that they are congruent, okay? So let's just write this out, okay? Same proof as last time. Here's the statement. Here's the reason. Okay, so the first statement is that angle 2 and angle 4 are vertical angles. Vertical angles. Okay, and that's given to us. Okay, angle 2, or I'm sorry, step 2, once we know that they're vertical angles, we know that they're congruent. So we can say that angle 2 is congruent to angle 4, and that's the definition of vertical angles. Okay? And I use a lot of abbreviations. If I put the angle and then apostrophe S, that means angles. Okay, I don't need to write out that word every time. Okay? All right, so then it says, okay, can we find all the other angle measures using properties of linear pairs and vertical angles? And the answer to that is yes. Okay, so given this situation, all right, here's what I know. I know that if I've got two intersecting lines, then I know that the angles that are across from each other, the vertical angles, are congruent. So I'm going to draw my little picture here. I'm going to come in here and say that these are both congruent here and that these angles are congruent here. All right, so therefore, all right, here's what I know. That angle 3, okay, that's the same thing as 54 degrees. Okay, they're congruent. All right, if this angle here is 54 degrees and it's across from angle 3, and they're vertical angles, then I know that angle 3 is congruent, or angle 3 is 54 degrees. Now, here's what I've got, okay? I have these two angles here that are, so I've got this angle here, and I have this angle here that form a straight line going across, okay? Because those form a straight line, I know that these two angles add up to 180 degrees. So check this out. So I've got angle 2 plus 54 degrees is equal to 180 degrees. Okay, and I set up this equation. This is what I create. Okay, so then I can solve for angle 2 and I could subtract 54 degrees from both sides. And as a result, we get that angle 2 is equal to 126 degrees, okay? So now that I've figured out that angle 2 is 126 degrees, okay, I also know that angle 2 is congruent to angle 4. So, you know, I know that if this is 126 degrees, then this angle here has to be 126 degrees because this is 54 degrees. Okay, so I can then assume and conclude that angle 4 is equal to 126 degrees. Okay, and guys, you have to create this. Okay, you have to sit here and you have to write out, okay, what's equal to what? What equations can I set up? All right, and then what other conclusions can I draw? So given one angle in a situation like this, you can figure out all the other angles, and we need to be able to do that. Okay, let's take a look at the next question. All right. All right, so here's what we've got in this one. Okay, it says that angle AEB, so AEB is 147 degrees. So I'm given this piece of information here. So angle AEB is 147 degrees. I'm going to write that here. I'm going to label my picture, call that 147 degrees. And then we want to figure out what is the measure of BEC. Well, what I notice is that when I draw these, angle AEB, this angle here, and angle BEC form a straight line here, okay? And so what that tells me is that they are supplementary, or is that those angles add up to 180 degrees. So I'm going to call this X here, all right? And if I'm going to set up an equation, I'm going to say that x plus 147, if I add those together, then that's going to give me a total of 180, okay? If I subtract 147 from both sides, all right, and solve for x, then I get that x is equal to 33. Okay, and since x is the measure of angle BEC, then I know that the measure of, I know that angle BEC, okay, is equal to 33 degrees. Okay, and that's what I'm trying to find. Okay, but notice how I had to set up an equation for this. Okay, you guys do need to show some work on this, set up equations and do all that. Okay, on the next one it says, what are the numerical measures of angle DHE and EHF? So here's what we know. We have these expressions here. We don't have actual values. So what I have to do is I have to figure out what x is. And if I figure out what x is, I can find what DHE is and what EHF is. So I want to find these angle measures. So, over here I'm going to write, that angle DHE is equal to what? And angle EHF is equal to what? Okay, and I want actual numbers over here. Okay, so before I do anything, let's go ahead and solve for x. And what I know is that angle DHE and EHF form a straight line. Okay, I keep doing this same thing. Okay, you don't have to always do that, but just run your pencil over and look what they create. And if they create a line right here, then you know that these two add up to 180. So I'm going to set up an equation, and I'm going to say that 2x plus 3x plus 5, okay, if I add those together, I'm going to get 180 degrees. Now I'm going to solve for x. So I've got 2x and 3x that I'm going to combine because they both have x's. I can combine those and get a total of 5x plus 5 is equal to 180. Okay, now to solve this for x, I'm going to subtract 5 from both sides, and I get that 5x is equal to 175. Okay, and then I divide both sides by 5 and by 5, so then x is going to equal 35. Now this is not the angle measure, this is just what x is. Okay, so x is equal to 35. Now if I wanted to figure out what DHE is, okay, I know that DHE has the expression 2x, okay, and I know that EHF has the expression 3x plus 5. So as a result, what I want to do here is I'm going to plug in, I know that x is equal to 35, okay, so I'm going to take this value here and plug it into both of the x's to figure out what those values are, okay. So as a result, I'm going to get that this is 2 times 35, which is equal to 70, okay. And you don't have to always just plug x in here. You know that these are supplementary. I bet we're going to get 110 out of this. Check this out. So I'm going to do 3 times 35 and then plus 5, okay? So that's going to give me 105 plus 5, which gives me a value of 110, okay? So I know that we have 70 and 110. Now the reason how I know that's correct is because these angles should add up to 180. And 70 plus 110 does give us 180. So here's what I know. My final conclusion is that angle DHE is equal to 70 degrees, and then angle EHF is equal to 110 degrees. Okay? And that's our answer. Okay, this is what we were trying to find. Okay, but now look, guys, the thing about it is I am doing some algebra here. So we must show work. Okay, if you're doing the assignment or you're doing the quiz and you don't have any scratch paper and you're not writing this down, folks, I don't know how you're going to get the answer. Okay, so if I notice that you're not doing that, I will request that you show me some work on this. Okay, all right. Now over here it says, what is the numerical sum of the degree measures of DEA and AEB? Now I'm going to go ahead and highlight this, and I'm going to say here's DEA, okay, that angle, and then AEB, okay, those form a straight line, okay? So if I add these two angles together, I get a total of 180 degrees, okay? And then it says, what are the numerical measures of the angles, okay? But we first have to figure out what x is, and then we got to figure out each individual angle. So I'm going to come over here, I'm going to set up an equation. Because they form a straight line here, all right, I've got the value of x plus 25. If I take that angle plus 9x plus 10, then that's going to give me 180 degrees, okay? If I add these two angles together, then I get 180 degrees, okay? You could even write angle DAE plus angle AEB equals 180, okay? You can write that. All right, now let's go ahead and solve this for x. So I have my like terms, so x plus 9x gives me 10x, okay? And then 25 plus 10 gives me positive 35, and that's equal to 180, okay? I'm just solving this for x, trying to figure out what I've got. And then I'm going to go ahead and subtract 35 from both sides. 35 minus 35. So we get 10x is equal to 145. And then if I divide by 10 on both sides and divide by 10, then that's going to give me that x is equal to 14.5, okay? So now I figured out that x is equal to 14.5, so 14.5. Now that's not the angle measure, okay? Now remember that DEA was just x plus 25. So I'm going to do this work over here. I'm going to say that angle DEA is equal to x plus 25, okay? Remember x is equal to 14.5, so I'm going to replace that here. So we get that this is 14.5 plus 25, okay, which gives me a total of 39.5 degrees, okay? And then I know that angle AEB had a measure of 9x, was it 9x plus 10? Yeah, 9x plus 10. So 9x plus 10. I'm going to plug in 14.5. So I've got 9 times 14.5 and then plus 10. So that's going to give me 130.5 plus 10, which gives me a value of 140.5 degrees, okay? And so here's how you can check this, all right? Angle DEA, that's 39.5 degrees. And this is 140.5 degrees. All right, and if I take both of those angles and add them together, all right, if I do 140.5 plus 39.5, it should give us 180. So if you add these together, you should get 180 degrees. All right, that's how you know if you're right, okay? All right, let's take a look over here. And I've got two problems left here. And on this first one, I'm going to separate them here. They didn't get changed. So here's what we know. We know that ABC and DBE are vertical angles. If they're vertical angles, that means that they are congruent, okay? The measures of ABC is 5x plus 1, and the measure of DBE is x plus 5. And it wants us to find the measures of both those angles. So here's what I'm going to do. I'm going to come over here and draw a picture. You can do this somewhere on this paper at some point. But I'm just going to draw a quick intersection. I'm going to call this point D, all right? I'm going to call this, not D, I'm going to call this B, all right? And I've got point A here, B, and then C, okay? And then I've got D here, and then point E. So I know that these are vertical angles. If they're vertical angles, then they're congruent. Okay, DBE is x plus 5, and the other one was 5x plus 1, okay? Now, the difference is that because these angles are congruent, because angle ABC is congruent to angle DBE, all right, I can set up the equation that 5x plus 1 is equal to x plus 5. Okay, and I have to solve this equation for x. So I'm going to go ahead and subtract x on both sides, and we get that 5x minus an x is just 4x plus 1, and that's equal to positive 5. Okay, I'm going to subtract 1 from both sides, so we get that 4x is equal to 4. Okay, and if I solve for x and divide both sides by 4, I get that x is equal to 1. Okay, so it wants me to find those angle measures. Okay, and so what I know is that if I find one of them, I know the other. All right, and if x is 1, I'm just going to take this value and I'm going to plug it into x up here. So I'm going to say that angle DBE is equal to x plus 5. Okay, but if x is 1, then we get that this is equal to 1 plus 5. So angle DBE is equal to 6 degrees, okay? All right, therefore, I know that angle ABC is also equal to 6 degrees because they're congruent, okay? You don't have to do the work if you already know something about those two, okay? If they're congruent and if one's 6, the other one has to be 6. Okay, let's take a look at this last one. Wants us to find what angle measures 1 and 3 are, and then what angles 2 and 4 are. Now here's what I know. These are vertical angles. Angle 1 and angle 3 are congruent. So if I wanted to set up an equation here, okay, I can easily do that, and I can just say that 2x plus 9 is equal to 3x minus 1, okay? Now, I want to solve this for x so I can figure out what angle 1 is and angle 3 are. But I'm going to go ahead and subtract 2x from both sides. And I'm going to get that 9 is equal to just an x minus 1. Okay, I'm going to add 1 to both sides and solve for x, so I get 10 is equal to x. Okay, that's my value for x. So here's what I know. Okay, we'll just do angle 3 for it. It doesn't matter. Angle 3 is equal to 2x plus 9. Okay, now if I take 10 and plug that in for x, then I get that angle 3 is equal to 2 times 10 plus 9. Okay, and that gives me 20 plus 9, which is 29. So angle 3 is equal to 29 degrees. Okay, so as a result, all right, I know angle 3 is 29 degrees. And if angle 3 is 29 degrees, then I know that angle 1 is also 29 degrees. Okay, so angle 1, from here, guys, we knew that angle 3, is congruent to angle 1. All right, so if those are congruent, then their measures are equal, and so we were able to set up this equation. Okay, now here's the other thing. All right, we know that if angle 3, all right, is 29 degrees, all right, I'm going to write that in here, that this is 29 degrees. Okay, then we can find out what angle 2 is. Okay, and we know that angle 3 plus angle 2 add up to 180. So I'm going to write that. Angle 3 plus angle 2 add up to 180 degrees. All right. Now angle 3, that was 29 degrees. All right, so 29 degrees plus angle 2 is equal to 180 degrees. So I can solve for angle 2 now. I could subtract both sides by 29 degrees. So I get that angle 2 is equal to 151 degrees. Okay, now if angle 2 is 151, so I'm going to come over here and write that if this is 151, okay, degrees, I know that angle 2 is congruent to angle 4 because they're vertical angles, and that is also 151 degrees. Okay, so guys, there is a little bit of algebra that goes on here and a little bit of your understanding of how this works. So I'm going to come over here and say 151 degrees. All right, so that's the idea. You need to be able to set up these equations and solve, and that's all I got. Thank you. Bye.